These little things here are Watchmaker's screwdrivers. Well, they're supposed to be Watchmaker's screwdrivers. When I buy tools like this, I do buy the cheapest possible things you can find, knowing that they're actually not going to work properly when you get them. They're going to need dressing up, sharpening up and maintaining, and then they'll work perfectly fine. The problem with sharpening these things is that they are so small you can't really hold a flat edge on the end of the screwdriver. Normally when you sharpen a screwdriver you can hold it down on the stone and rub it like this. Well, they're too small. So with a bit of 8mm bar and some little 11mm ball bearings, I'm going to make up a sharpening guide so that we can dress these up nicely in the future. First thing is to face this off and turn this diameter down so that it will take this little ball bearing on the end there. That's a 4mm bore in that ball bearing. There will be one bearing on each end of the guide, pressed on at the end. What I'm going to do now is set a stop on the carriage at 4mm, which happens to be the width of these parallels. So that when I move the carriage in, it's only going to move down 4mm. The right depth of cut. So that's 4.03mm. 0.3 will be enough for a press fit, I think. So I've measured the length of this, 52.16. I want it to be 48mm long. So I've zeroed the tool tip on there, put a 4mm gap in on the stop, and then I'll wind the 0.16 in on the top side. Once I get the 4mm off, that should get it approximately to length of 48mm. Doesn't really matter how long it is. Okay, so that should be 48mm long. The tool is zeroed off on the face of it because I've just cut that. I want to make the same 4mm shoulder again on this end. So a 4mm parallel, creating a gap between the carriage and the stop. then just take that shoulder down to 4mm. I'm hoping 4.2. .35, so quarter of 0.32 is 16.8. .01 will do for that. Okay, so that's the bar. It's got a area for a bearing at each end. I've now got to drill and tap a hole at least through to halfway, which will be ready for an M3. I'm just going to have to go in pretty much up to those chuck teeth, chuck jaws, chuck teeth, there's no such thing. Okay, so that's 0 on the tailstock, back it off a bit, and let's see if I can get in there. That was a matter of pecking away at it, knowing that these flutes are filling up with swarf, and if they fill up and jam, then it will snap because it will seize up. But always a bit nerve-wracking drilling a long thin hole. You get very little feel on the size of this machine. Good, now to tap it. So I'll get this straight and then back it out, finish it in the by hand in the vise. That's enough. Because of the lack of feel, there's always a risk that that's going to break the tap off if it starts to jam. You can't feel it. So I'm in the centre of the bar, having zeroed out on the fixed jaw and the end, found the middle of the bar. Now it's time for a 5mm hole. I'm not even going to use a reamer on this, it just needs to be a 5mm hole to take the screwdriver shank. It's a good spot, it doesn't deflect when it goes in. And that's going to need quite some deburring because it's horrid material. What I don't want to do is drop that part all the way through the bottom of the vise into the T-slot, because that will that'll be painful. So one of the famous magnets, and that takes care of that. So look at the state of that, look. Goodness me. So I need to finish tapping that hole as deep as I dare to. I don't need the thread to be all the way down, but just start using this thing. I don't want to be confused with the thread binding up and with the tool tightening up like it's supposed to. Now that hasn't cut the thread all the way through that hole, certainly not fully, but that doesn't matter because I'm going to put a pin inside that hole that's going to come up about halfway, so that the lock screw is actually going to bear down on a pin inside the hole to trap the screwdriver in it. That's all the machining of the thing done. Thread in the end there. Just a matter of pressing the bearings onto the end. If I've got the press fit anything like right, yeah, still rolls. I haven't crushed it. The press fit on this end with this bearing is far too much, and it actually breaks the bearing as I press it on. You can hear it cracking. That one's a bit tighter. And that, I believe, might have broken. This one's okay. That one with all the cracking it's doing might be split, or if not, it's certainly expanded, so it's going to have to be removed. One of the other ones I put on is one way of removing ball bearings. Yeah, that's it, that's that off. Here we go. So to stop that happening again, I'll just try and give this a bit of relief. Yeah, it's nice and gentle, so they're both on there anyway, both turning nicely. There's the bearings on each end. This is a clamping pin, 2.5mm going in an M3 hole, M3 screw. These screwdrivers shanks are like 4.5mm, nearly 5. That's the plan. So once that's properly set in there, rest it on the whetstone, sharpen the blade like that, then flip it over and sharpen the other side. Should be able to hone those in square. Let's see what happens. Now, I had previously sharpened these screwdrivers just using fine files, but pretty poor results, and it was almost impossible to sharpen the smallest two of the set. But now, with the ability to hone each side at a time and get them parallel to each other, you finish up with a much finer and flatter and squarer tip of the blade. There is a large included angle on these though. It's probably a benefit for someone like me, because I will tend to over tighten very tiny screws, and I have broken them in the past, but with a large angle like that there's some hope that the screwdriver will cam out of the slot before it gets to a point where I'm going to snap the screw off. But they are overall a much better result, especially on the smaller ones. We'll have to see how they go.